So I've got a question here, got a uniform plank PQ, it's horizontal and in equilibrium. And here is a picture of it here. And you see it's 7 meters long. Now it's supported by two trusses, X and Y. Y is 2 meters from Q and X is 1.4 meters from the point P. The force acting on the truss X is 4G newtons. That's the information we've been given, and we want to try and find the mass of the plank from that. Now, important to know that it's a uniform plank, so that means it's the same thickness and weight all the way along, and it's in horizontal and it's not moving. So therefore all of the forces acting on it are all equal to each other as it's not moving. Now this question here is a classic moments and pivot style question, because what will happen is here the forces acting on this will create some sort of rotation. If I move this truss Y out of the way, the plank is just going to fall down, so there must be some sort of rotational forces keeping it in place. So the good thing is with pivot and moment style questions is you can put the pivot point wherever you wish and you will still get the same answer. The key is to try and put that pivot point in a place where it makes it easier to find the answer. That's the skill in mathematics to try and do that. So we need to find the mass of the plank PQ. So to find the mass of that, I don't know what this force is here, but I know what this force is here. So I'm going to use this one and maybe set that as my pivot point, because that will then have no effect because it's not moving. So I'll set my pivot at Y, and I can either go clockwise or counterclockwise. I'm going to set it to counterclockwise, so my forces will go in the rotational direction of anti-clockwise. Okay, right, so what forces are acting on the plank if the pivot point is Y? Well, this truss is stopping the plank from falling down, so the forces are going to be going upwards, and it's been given at 4G newtons, and it's going against our counterclockwise direction. So what I will do is, first of all, I'll write this as a minus. So I've got minus 4G newtons, and then I also need the distance from the pivot point Y to X. Well, if the whole thing is 7 and this is 2 meters from the edge, this PY is 5 meters, but X is also in 1.4, so that leaves me 3.6 meters. So minus 4G newtons times 3.6 meters. Okay, so that's the first force. Now the only other force is the weight of the beam pushing down. So this force will act, as it's uniform, it will act. So that will go in the downwards direction. Now we want to find the mass. So the force acting on that will be mass times the gravitational constant newtons. So what's the force of this acting on that? Well, we've got mg newtons, and then what's the distance from here to here? Well, if this is in the middle, this length here is going to be 1.5 meters. So that's 1.5 meters from there to there. So I'll multiply this by 1.5 meters. Okay, now as it's in equilibrium, the forces are equal, so therefore it equals 0. Okay, so now what I can do is I can now rearrange this equation to get the minus value on the other side. So I can have mg newtons times 1.5, and that equals 4g newtons times 3.6. Okay, so I don't need to put the meters in there for the moment because newtons is newton meters is its standard value anyway. So okay, what do I need to do now? Well, I've got mg, I've got 4g. Now if I divide both sides by g, I can eliminate the gravitational constant, so I don't need that. The newtons for the moment I don't need, so I can eliminate that. So now I've got 1.5 m equals 3.6 times 4 is 14.4. So that's what I've got so far. So now to just solve for m, I just divide both sides by 1.5. So M equals 14.4 divided by 1.5. So the mass of the plank is 9.6. 14.4 divided by 1.5 is 9.6, and that's kilograms. So the mass of the plank is 9.6 kilograms. So that's the first bit taken care of. Now we need the reaction force on the plank at Y. So what force is this creating? So now we know this force, we know this force, we don't know this force. So we can set a pivot either here or here. So I'm going to choose to set it at this point X, because that looks like the easiest one to do, because then that just becomes 0. So now pivot at the point X, and we can go counterclockwise again. That's absolutely fine. You can pick wherever you want and which direction you want for each of the pivots. So this is what we got so far. Now let's keep this separate. That's the answer to the first part of the question. So at X, what's happening at X? Well, we've got going in the, let's stick to this direction, the counterclockwise. We've got this force Y. Now acting on that, as it's going to be going upwards, we'll use capital M G newtons. That's the force acting on the pivot here at Y. So that force there, mg newtons, so I'll write mg newtons, capital mg newtons, and multiply it by the distance from the pivot. So what's the distance? Well, we know this bit's 1.5, so this bit here, if this is 3.5, we're left with 2.1 meters to go along this part. So 2.1 meters, and then plus this, that gives me 3.6. So mgn times 3.6, so that's in meters. So that's the length for Y from X. Now this force is going down, so that's going in the clockwise direction. So that's going against, so that's minus against our counterclockwise. It's 2.1 meters mgn. So we've got 2.1 times 9.6 g newtons. And then that again is set to 0. So as we did before, what we can do is we can set this, so this side on one, this on one side, this on the other side. So let's do that. So now I've got mg newtons times 3.6 equals 2.1 times 9.6 newtons. So that's taking care of that. So now I don't need the g. Actually, I'll put that, I forgot to put the g in there. I don't need the g's, so I can divide by g on both sides, so they can be eliminated. I don't need the newtons for the moment. So now I can solve for the m. So these will cancel, just take those out. So I've got 3.6 m equals 2.1 times 9.6, which is, put that in a calculator, we'll get 20.16. So therefore m equals 20.16 divided by 3.6, which will give us 5.6. So the reaction force on the plank at Y is 5.6 newtons. So that's the force on the plank at Y. So 5.6 newtons plus G, times G, so G newtons. Okay, so that takes care of that. Now the last part of the question asks us, if Qy suddenly becomes 1.4 meters, does the plank remain in constant equilibrium? So if the forces aren't changing, we've then got a slightly different diagram. So let's just draw this diagram a little bit different. The force acting on the plank is in the middle. We've got this force here, which was 4g newtons. We've got this force here, which was 5.6 g newtons. And those forces were the same distance. So this distance here was 2.1 and 2.1. And the force acting down still remains constant. 9.6 was m, so 9.6 g newtons. So that's the force acting downwards. Now here we can see the forces here are different. There's more force upwards and more force than this force here on the left hand side. So this 5.6 is obviously greater than 4. So there's more force going in this direction. Now with the distance from the pivot, if this was the pivot, is now the same, this is now going to rotate. So this would not remain in equilibrium. So not remain in equilibrium. I'm just going to put equilibrium like that. And that's the end of this question. That's all good.